Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for each function, determine whether the critical point is a local maximum or minimum, and whether or not the tangent is parallel to the horizontal axis. So now critical point is a point where the derivative of the function is equal to 0 or undefined. So in order to find the critical points, we have to find the derivative of this given function. So let's start with that. So y prime, so for this function we'll have to use chain rule because there is this inner function x minus 5 and then the outer function is the exponential function with exponent 1 over 3. So we start with the derivative of the outer function, and for that we'll have to use the power rule. So we move the exponent to the front times x minus 5 and we subtract 1 from the exponent times the derivative of the inner function, which is x minus 5, and the derivative of that will be 1 minus 0. So 5 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So in the exponent, we can do 1 over 3 minus 1, which is equal to negative 2 over 3. And then 1 minus 0 is 1, and multiplication by 1 doesn't change anything, so it goes away. Now in the next step, we can move x minus 5 to the denominator to make the exponent positive. So x minus 5 goes with the 3. Now we have to find the critical points. So for that we have to find the x values at which the y prime is equal to 0 or undefined. Now in this case, there is no x value that will make the y prime equal to 0, because if we sub in y prime as equal to 0, then we'll have to cross multiply the denominator and that will make the x go away. So it will become 0 equals 1. So now we have to see if there is any x value that will make the y prime undefined to find the critical point. And y prime will become undefined if the denominator becomes equal to 0. That means x minus 5 should become equal to 0. And that will happen if x is equal to 5. So if we isolate x in this equation, we add both sides. The 5's on the left side get cancelled out. So x equals 5. So this is a critical number for this function because at x equals 5, the denominator becomes equal to 0 and as a result, y prime becomes undefined. And now we can find the y value for this x value so that we can find the critical point from this critical number. So we get y equals, so we sub in x as 5 in the given function. So 5 minus 5 exponent 1 over 3, and 5 minus 5 is 0. So 0 exponent 1 over 3, which is equal to 0. So the critical point is 5 comma 0. So this function has only one critical point, 5 comma 0. Now we have to determine whether this critical point is a local maximum or minimum. So for that we'll use the first derivative test. and we can use the number line method. So we'll start by drawing the number line. Now we can show the critical number, which is x equals 5. So this critical number divides the number line into two parts. So we have to find the value of y prime to see whether y prime is positive or negative on the two sides of this critical number. So we'll use a test value from each side. So for the left side of x equals 5, we can use the test value 4, and for the right side we can use 6. So now we'll sub in these test values in the y prime equation. So let's start with x equals 4. So we get y prime equals 1 over 3, and then parentheses 4 minus 5 exponent 2 over 3. And now we can simplify this expression. So 1 over 3, so 4 minus 5 is negative 1 exponent 3. Now we can simplify this expression. So 1 over 3, so then we get negative 1 square and then cube root. So there is a very important concept we need to understand about simplifying this kind of expression. So square of negative 1 is positive 1. So we get 1 over 3 and then cube root of 1, and cube root of 1 is 1. So y prime is a positive value 1 over 3. So that means the function is increasing on the left side of the critical number x equals 5 because y prime is a positive value. Now we can analyze the sign of y prime on the right side of x equals 5. So we'll sub in x as 6 in the y prime equation. So 1 over 3 times 6 minus 5 exponent 2 over 3, and 6 minus 5 is equal to 1 exponent 2 over 3, and 1 exponent 2 over 3 is equal to just 1, so we just get 1 over 3. So again we got a positive result for y prime, so that means the function is increasing on the right side of x equals 5. So now we can find out where the critical point is a local maximum or minimum. Now in this case, the function is increasing on both sides of the critical number x equals 5. So that means the critical point represents neither maximum or minimum. So we can write our answer. So critical point represents neither local maximum nor minimum because the y or function y is increasing on both sides of critical point. So we are done with the second part. Now we have to find where the tangent is parallel to the horizontal axis at the critical point. Now we got the critical point by setting the denominator equal to 0. So that means the critical point 5, 0 was obtained from the critical number x equals 5, and we got that now critical number by setting the denominator equal to 0. So at x equals 5, y prime is not equal to 0. So now tangent is horizontal if the derivative of the function is equal to 0. So there is a very important concept we need to understand and memorize. So therefore, slope of tangent is not equal to 0 at 5, 0, the critical point. So we can conclude, therefore, tangent is not parallel to the horizontal axis. So there is a very important concept we need to understand and memorize about analyzing functions to find whether the tangent is horizontal or not. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.